Hello, this is pi snake is not equal to 4. I think that's what you say. By Tulrak, or I hope I'm not butchering that name either. So, this is actually a puzzle with a very interesting rule set, a lot different from what we've been doing in the channel so far. So let's go through that. Normal Sudoku rules apply, so digits 1 to 9 in every row, every column, and every 3x3 box. So that is a normal rule. Next, color 25 orthogonally connected cells to create a 25 cell long, 1 cell wide snake. So a snake could look like this. That is what a snake could be like. So it's basically like a long hallway that is 1 cell wide at all times. The snake does not branch, so something like this is not allowed. The snake does not touch itself orthogonally, so something like this would not be allowed. So you couldn't have a snake do that. The snake contains the first 25 digits of pi in the correct order going from head to tail. And the 25 digits of pi are written here. I think it looks a bit small, but in order it is 3.14159265358979 3238462643, and those are the first 25 digits, I believe. And so along your 25 digit long snake, I'm not drawing 25 digits, but like say your snake looks like this, then your digits must go 3.1415. Ignore the bit at this point, but your snake must have pi on it basically. So it is a pi snake. And those are the rules. Yeah. And your snake can't touch itself. You can't touch itself diagonally, so the snake could do something like this, I believe. So this is fine for the snake to do. Like this is fine. Even if the snake touches itself diagonally, that's fine. It cannot touch itself orthogonally like this. That's not fine. But otherwise, it can just do whatever it wants. And has to contain pi on it. The digits are very generously given here. I think these are the first 25 exactly. Alright, so those are the rules. With that, let us begin. Alright, and the circle marks the head, right? Yeah, this is the head. So that is part of the snake. That is part of the snake. Wow, I can't speak today. I'm gonna mark it with light blue because it's a nice blue color. Okay. So let's see what we're up to. The snake's second digit must be a 1, so it must grow in one of these directions, clearly. So 1 is in one of those cells. But I noticed something pretty interesting about the number pi, is that very early on you have a duplication. There is another 1 somewhere. The 4th digit is also a 1, which means I'm pretty sure it can't go this way, because then how do you get out? Whatever you do, the 4th digit will always be in the same box, which then coincides with the 1 here. So I don't think this can be a 1, and I will mark that as non-snake. I guess I'll use gray for non-snake. So yes. No, actually I don't think I'll use gray for non-snake. Let's use pink for non-snake, shall we? I don't know. Is this a bit? I think it's fine. You'll understand, maybe. Light blue snake, pink is not snake. So 3 goes in one of these 2 directions. I think I can't go this way either. And the reason why is because no matter what you do here, you cannot avoid having the 1 not see this 1. So this is the second one. If you had a 1 here, then you couldn't have this snake grow in some direction where it doesn't see the next 1. So like it can't do this and see a 1 here, that coincides. It can't bend because the 1 stays in the box. Can't go out this way, can't go out this way because the 1 stays in the box. So no matter what you do with this 1, I do not think it can be snake. Which means that the snake must grow out this way, and that digit is a 1. Now the 4th digit is also a 1, which means it cannot be in the same box. It also cannot be in the same row and column as this one. So I think the only way to do that in 2 steps is to hit this cell. Because it can't hit this cell, it can't go in this direction. Yeah, so it has to hit this cell, which means this cell is in fact the 4th digit and is a 1. Although it can do so in a couple of different ways. And that wouldn't contradict anything, but we know the snake so goes in this way somewhat. I also noticed that after the 1 comes a 5, and wherever you go from this 1 cannot hit a 5 that is not this cell. Because wherever this 1 goes, it would stay in the same box. So it has to be this 5 that it touches. That's part of the snake. And the snake can't branch, correct? So whichever way it goes, a step in this direction would be a branch outwards. So this can't actually be part of the snake either. Alright, so let's think about... Okay, the first 25 digits, very interestingly, ends with a 3. So I'm wondering, can this be part of the snake? It can't, because if it was, it would have to be the tail, it would have to be the very end. And therefore would have to be a 3, which then coincides with that 3. So this can't be part of snake. I mean, these can in fact be part of snake though, because your snake could go this way and then walk like this. That's possible for snake. Okay. After this 5, I think is 9 and 2. Okay, I mean it can touch this too, but I'm pretty sure it doesn't have to. It could do something like this and hit a 2 here. That's fine for a 2 to be there, so it can do something like that. We know that the 5 has to go in one of these directions. It can't go this way though, yes. Because if it went this way, then the next cell is a 2, which has to be one of those, which doesn't work. Because there's already a 2 in the box. So it can't go this way and therefore must go in this direction. So one of those is a 9. Now again, this doesn't have to be part of the snake, because the 2 could be one of those cells, which is part of the snake. But that means this is not snake, because the snake goes in one of these 2 directions. And in fact, I don't think that's snake either. Yes, because if it went 9 this way, it could only reach 2 this way or this way. It can't reach 2 here, because there's already a 2 in the box. And this can't be the end of the snake either, because there's already a 3 here. So this can't be end of snake, meaning this cannot be snake at all. No, this can be snake. What's up 2? After 2 is 6. 6 might be a bit far to think about right now. Okay. I'm gonna take a bit of a look at the puzzle itself. It looks like someone has solved it and rated it a 2 out of 5 in difficulty. So it should not be too difficult to see what is going on after this. Oh, my door just closed there. So that's part of snake. I really don't see how we can disambiguate which direction it goes in. So maybe we don't look at that. After this 2 comes a 6, right? And then we know because it goes in one of these directions, the only other directions it can go is here or there to continue the 6. But if it goes in this direction, it has a lot more options. And then after the 6 comes another 5. Do we even think about it that far? That is really far. Oh yeah, we know one of these are 4s. They could both be 4s as well. But at least one of these are 4s. Does it say anything about having to touch the given digits? No, it doesn't say anything about having to touch a given digit, so it doesn't have to touch this 2 at all. Even though it has touched every given digit we've used up so far. Can we figure out what's also not snake? Like, can we say something about this being snake? I mean, again, we can always do something like that. Or I guess 1 is in one of those cells. Oh, that's interesting. After these two ones, it doesn't see any 1 at all. If you see those 25 digits there, it only sees those two ones and that's it. No other ones in the entire length of the snake. So that's pretty interesting because 1 goes here. Oh, but that's not entirely useful at all because we know that the snake must... If a snake went this way, it does enter this box somehow and therefore must exit the box via the downwards direction. But it doesn't really say about anything. I was like, it doesn't have to touch the 1 by going down. It could do this, forcing a 1 into one of those cells. But we know 1 is in one of those cells, definitely, which is not touched by the snake. I wonder if there's any other big pieces of logic that we might have to consider. Because along the line, you see there are a couple more intricately placed digits. Like there's this 979 section here, which is quite interesting because I don't think that means that this 9 can be part of the snake. We already have a 9 in the very beginning, but that 9 is one of those two cells. The other two 9s are in the 979 section, but this can't be part of that 979 section because the 979 section, no matter how you leave this section, no matter how you leave it, you cannot leave the box fast enough for the 9 to repeat. Or you cannot enter fast enough, or you cannot enter slow enough for there to be a 9. Yeah. Whatever you do with this 9, if it was part of the snake, it would hit another 9 in the box. So I don't think this is part of snake. Not exactly sure how that helps. But I would assume there are other... Yes, right. After this 6 that we're looking at, there's a 535. 535. And in fact, I think it's pretty interesting where this this kind of like repeating digits go. And in fact, there's something even more interesting. There's a 46264 there. Wow. But if you think about it, let's say we had a... Somewhere we had a 535 somewhere. How would that work? I'm going to put the small digits in and say that wherever that is, that must be on the border and it must be two cells diagonally adjacent to each other like so. And the reason why is wherever you have 5, I put a 4 there. I mean, wherever you have 5, the other 5 has to be 2 cells away. And the only way to do that without conflicting is to move one cell here and one cell away from it. Because if you move 2 cells in any straight line, then your 5 will be in the same row or column as it. So it doesn't work. So wherever you move, your next step has to be in one direction in the second axis, if you understand what I'm saying. And therefore the 5 must be diagonal to it. But even then, they cannot be in the same box, and therefore would have to be across a box border. Which is fairly interesting because that forces a 5, or that forces the next 5 to be along the border. I'm not sure what that means exactly about where this snake goes. Because you could always go 5, 9, 2, 6, 5, 3, 5. But it has to be along a border. So can I say, can it go in this way now? After this 9 comes a 2, and then a 6, and then a 5, and then a 5 goes there. Okay, that is fine. So it can still go in here. Can it take this 2? If it does, it would have to go in one of these directions, putting a 6 there. I guess so, because after the 6, you could put a 5. Oh, wait a minute. Wait. So, oh yeah, whoa. That is really interesting. After this 2, a 6 must be one of those cells. Because 9 already goes in one of those cells, which eliminates the other cell from being part of the snake. Right, otherwise you have a 2x2 area. So it's either here or here to get to this 2. Which means that your next digit after 2 can only be here or there. So one of those digits would then have to be 6 if this 2 was part of the snake. And from those digits, how do we get the 535? Well, this digit being a 6 does not help. Because if that was a 6, you would have a 5 immediately after. Oh, but it could go this way, couldn't it? It could be a 5, 3, 5. It could do that. What about here? I mean, I was looking at this. How do you make a 5, 3, 5 there? Because after this goes down, you can't go this way unless you have a 5 here, which blocks like that. That has to be a 5, right? And so now where can the 3 5 go? The next 5 cannot go this way, it can only go this way. But if that was even true, how would this even get out? You can't go like this, so you have to go like that. That's what your snake has to do. And now it's stuck in this box, so there's no way to get out without touching itself. Which means that this can't go down this way if it was part of the snake. Again though, I think this is a valid option. You have a 6 here, and then this can never be a 5 because we already saw how putting a 5 here breaks the 5. So that you have a 5 there, which could do this. So you could have a snake going that way. Because after that 5, you then have like a 3 8 9. Sorry, you have an 8 9 7 9 whatever. And then that one we should not be thinking about at all. So yeah, this too can in fact be part of the snake. Oh, that's really frustrating. What cannot be part of the snake though? I mean, like, this could be a 6, right? If you had like a 5 here, and then 3 5, that's fine. And then this could also be where the 2 goes. Wait, what? 2 could go here. This could be a 6 5, and then 3 5, and then this is fine. And it could go here as well, the other 2, because you could go like 6 5 3 5, something like that. That's fine. So what now? Okay, well, where else does that take place? I mean, there's a 9 7 9 somewhere, but we don't even have that. And then the next section is the 6 5 6 section. Sorry, the 6 2 6 section. Okay, well, I can say that this snake isn't, this 6 isn't part of the snake, because there is only a number of, there's only this 6 that we're looking at. After this 2 comes a 6, which cannot be that one, definitely. After this, wherever the 2 is in here, can't be that 6. And then after that we have a 6 2 6 somewhere at the very end, but this can't be it either, because this isn't touching a border. We already knew that for those repeated digits in that specific section, you'd have to cross a border diagonally, so that can't be snake. But that 6 2 6 looks pretty intriguing. It can't be across this border. It could be across any other border though. But what happens to the 4? If 6 crosses a border diagonally, how does 4 have to react? If a snake crosses the border, the 4 must be... Well, the 4 could be anything, honestly. The 4 could do that. That's fine. What about a 9 7 9? Can this be part of the snake? Oh yeah, the entire section only has one 7 as part of the snake. So if this was part of the snake, it would have to be the 7 between the 2 9s. How would that work? Well, it wouldn't, because... Yeah, well, it wouldn't, because you need to cross a diagonal border. But the only way to do that is to have it do this or this. Either way, your snake gets locked into this box and can't get out. So I don't think this can be part of snake either. The only issue is that the snake could still go like that. I think that's fine, depending on which section of snake we're looking at. Oh wait, there's a 3 2 3 there. Yeah, after the 9 7 9 comes a 3 2 3. So in fact, this is quite restricted. What can this be if this was snake? Like this would have to be a set of 3 non-repeating digits. I mean, could it be something like... Oh, this can't be 979 323. It can't be anywhere from there. The reason why is because from the 979 323 section, 2 of those digits must be repeating. In fact, if the snake went in here, then all of these are definitely snake, because that's the only way snake can go in. Making these non-snake would prevent a snake from going in at all. That is, unless the snake ends right here, in which case this can be non-snake. And I think this can actually happen. But in that case, then this wouldn't even be part of the 979 323 thing. So let's assume this was snake. And let's assume this was the 979 323. What is wrong with this is that the repeating digit must be diagonally one of these, right? So either you'd have, you know, 9 9 here, or like I guess you could have 9 9 here, or I guess you could have 3 3 here, or I guess you could have 3 3 here. The thing is that because these two sets of repeating digits or palindrome sections like 979 and 323 are exactly adjacent to each other, whatever this is, if this was a 3 or a 9 somewhere, that does it work? This can't even have a 3 in it. What the? Yeah, that 3 sees that, so they can't even have a 3 in it. Huh. Wait a minute, wait a minute. I feel like this is not snake. I just can't explain why. So, how would this be snake? If this was snake, where could it even come from? Wherever this 5 went, it will have to be. It will have to go pretty far. I mean, it could always just go this way. So that is the shortest it can take to reach this path of snake. In which case, we would be at like the we'll be at the 535 section, wherever that is. So this is at least after the 535, right? Because 5 2 6 and then oh no, we wouldn't be. Because it'd be 5 9 2 6 5 3 5. Oh, I mean there are a lot of 3s, so that is pretty pretty tough to fit. Yeah, like which section of these digits could it be? It could be what, 5 8. It can't be 979, can it? Because there's 9 here. Because 3 actually appears a lot. There's a 323 section which is nowhere here at all, because the 2 sees that, the 3 sees that as well. So in fact, because this is after the 5 that we first saw, this must be after the 3 in this section, which is the 58979. And then, yeah, this must be part of 58979 somehow. So 5, 8, 9, and then 979 is very pushed into this back end. The only other way you could ever get into here was if you went the other way, but that takes so many more cells. I'm pretty sure you can never get here by the time you reach the 8979 section. That is really tough to look to see. I don't know if that's even intended. But I think it's safe to say that you cannot have this 8979 section here, because you'd force a 9 into this this back end over here, which clashes with this 9. Otherwise, could you have this be 9 7 9? No, because this would then be 3 2 3, which clashes. So either you go in early and end with a 9 in this cell, or you go in with a 9 and end up with a repeated digit here, right? 979. Yeah, because 979323 is actually very interesting. However you put the 979, because they must be in adjacent digits, the next cell in this sequence is always going to be somewhere where you cannot do that. Yeah, that's what I'm saying. That's what I'm trying to prove. Wherever your 979 is, the next cell cannot be a 323. Okay, so what else could it be? Well, after the next 3, you'd have 8 4 6 2 6 4. Is that possible? 8 4. Let's think about that. Like 8. See if I can make that work. 4 2 4 6. Sorry, I can say 4 6 2 6 4 3. Whoa. Okay. Okay. Well. Okay. Between the 3s, you have an 8 4 2 6 4. Okay. So these must be from the 8 4 2 6 4 section, but can't be 6 2 6. Could it be 8 4? No, because the 6 2 6. How does a 6 work? If it's 6 2 6, it must be diagonally crossing, which can only happen in here or there, right? So 6 would have to be there. Then you'd either have 8. Sorry, 8, 4, 6, 2. That breaks already. Yeah, 2 can't even be there. Yeah, wait. None of these digits can be 2 or 3. Whoa, that's really interesting. None of these digits can be 2 or 3. So from this 3846264, how can you have 3 cells in a row that aren't 3 or 2? The only set of digits working from that section is 846. But that forces 6 to be one of those cells, which doesn't work, because 6 must repeat, and therefore must cross diagonally. So this 846264 thing does not work in this section. Okay. So we can rule that out. Then before this 3, I wanna try to see if I can explain that again. Before this 3 we have a 58979. So I'm just gonna write that down. 58979. And that is how we're trying to fit. That's what we're trying to fit into this snake. Because those are the digits between 3s. Right? So from there, what can we place here? Well, because we know 9 has to diagonally jump across, then the 9 has to be here, right? 9s cannot be here or there, because whatever we do with that, unless you had a 9 here somewhere, which can jump from there. But that also doesn't work, because that kind of forces this to be a 3, I think. So let's say 9 can't be there. 9 can also not be there, forcing a 9 to be there in this section, because we know 9 must be in there somewhere. You can't have 3 digits that are not 9 from this set. 3 consecutive digits are either those cells. Actually, in fact, because we know those are 3 consecutive digits, we only have 2 options. It's either 589 or 897, because 979 doesn't work, clearly. But 589 doesn't work either, because we know that forces a 9 into the outside squares, which we already know doesn't work. So we are left with 897. And because we know we're coming from here, if we come in from the other side, that takes too many cells. We can never reach here in time. So then this would have to be 897, which works like that. And that fails because that forces a 9 there, which clashes with this 9. So this also can't be from this 58979 set. Which means that because it doesn't have a 3 and it doesn't have a 2, we have ruled out every possibility for this to be part of the pi snake. Which means that the pi snake can never enter in here, can never exit through there. So this can never be snake, right? None of these can be snake. Unless it goes something like going backwards, and then it goes in 8, 4, 6. And then 2, 6 here. Is this fine? That is one way that I have not thought about. Something like this. Is this fine? What comes before that? I mean, 3 comes before that. And then what comes before that? A 2. Oh, this looks vaguely possible. 3, 2. Oh, but then this 3 doesn't work because 3 must repeat and cannot cross another diagonal border. So this doesn't work either. I think this was our last option, which does not work either. So I think now I can confidently say that this is not where the snake goes. Snake can't go in here at all. So those are all not snake, I think. That was such a stupid thing that I don't even know if that helps or not. But that's not snake. Yeah, I'm pretty sure that's not snake. So what is snake? These are only ones on the snake, so that's not snake either. Okay. Okay, I mean that's not snake. Wait, I mean it could be snake if it ends yeah, if it ends here, yeah, it could be snake. That would be a 3. Oh, but that doesn't work because this 3 would have to see a 6 somewhere in these cells. So this can't be snake. You can't put a 3, can't make it the end of a snake either. Okay. That's so weird. What am I doing with this? Where am I going with this? After the 9 comes a 2, which then happens to be a 5. And then it would need to be 3, 5. No, after the 2 is a 6. After the 6 is a 5. How do I prove that these don't work? Or one of these or 2 of these don't work? 6, 5, 3, 5. After 5, 3, 5 is 8, and then 9, 7, 9. This is not 2 out of 5 difficulty. This is not 2 out of 5 difficulty. Unless I'm missing something very, very, very obvious. There is no way this is 2 out of 5 difficulty. I so desperately want to color that as snake, but I know it doesn't have to be. I have to find some other way to prove that it's not. The fact that one of these are 1s is sort of intriguing, I think. Oh my goodness. 2. Can I say that none of these are snake? The only way to enter this is if you did something like that. Could you somehow figure out a way to do this? I think there are too many sets of palindromic sections. There's a 5, 3, 5, there's a 9, 7, 9, 3, 2, 3, 6, 2, 6. In fact, the only way to get through here is to do this, right? Which means that all of these are snake, all of that snake. So at least 6 digits in a row must be different. And in this set, I don't think you can find 6 consecutive digits that are all different. Can you? No, I think the best you can do is you can do 9, 3, 2, 8, 4, 6. 7, 9. Yeah, I could do something like. It could do something like how do I do this? 7, 9, 2. Wait, no, you can't. Yeah, after 7 is a 3. Wait. Yeah. What? Is it 2, 3, 8, 4, 6 is the longest you can go? I think 2, 3, 8, 4, 6 is as far as you can go. 5, 9, 2, 6, 5, 3, 5, 8, 9, 7. Yeah. There are a lot of subsets of 5 length that don't contain repeated digits, but I don't think in there is a single set of 6 that contains no repeated digits. Yeah. So in fact, if you went in here, right, you know that these cells are all part of snake, which then fails because no single set of 6 digits within those first 25 digits of pi contain no duplicates. So your snake can never enter this section, and so those are not snake. Weird. But if you did enter this section, what would that say? Well, if you did enter this section, you'd need at least 4. Does that work? I mean, I think so. I think it would work. So we can't really do anything with that. That's so annoying. That is really annoying. There's a lot of sets of 5, which is there's a lot of sets of 4 as well, which makes it entirely possible to go in there and out again. 926535. 926535. 6535. There's a lot of fives in there. I mean, there's a lot of fives in here as well. You could have up to like 3 fives in this area. 6535. 926. Here's it doesn't work. 926. 926535. And then if it's 92, you couldn't have 6 here, then 535 or wait, 926 535 8. Oh, maybe it's what happens after. Yeah, I think what happens after is more interesting. Because alright, okay, let's say we went in this box somehow, somewhere. You have to exit the box again. And to enter this box at all, I think you have to do the 535 thing very specially. So your 535 would have to cross a diagonal border. Oh, but it could go something like 2 6 2 6 5 3 5 8 9 7 9, right? You could do that. We have enough digits for that. And then like 3 2 3, that's fine as well. Oh, that is a possibility. No, I was like, maybe you can't go in this box because then you wouldn't have enough to get out. Maybe you wouldn't if it went this way. Maybe if you went like 2 6 5 3 5, but then we can do the exact same thing here. What if we went this way though? If we went this way, I mean, it's even easier if we went this way, I'm pretty sure. Maybe not though. Maybe the 7 and 9 mess things up. Although I'm pretty sure you could do 9 7 9 here and just evade all the 7s and 9s. This is a valid string, I think. So you could have a... Well, I mean, this looks pretty hard to get, but I can't prove that that's the only... It doesn't work, right? So if you went this way, if this snake went this way, how would it work? You'd have a 2 there. You need a 6 and then 5 6 5. 5 3 5, sorry. So wherever the 6 is, if it kept going this way, wherever the 6 is one of those cells. And then 5 would need to... Well, yeah, 5 would be pushed, in this spot. I think 5 is only there. Because if the 6 was one of those cells, a 6 here pushes a 5 into one of those cells. This sees that, so 5 would have to go there. And then if 6 was here, 5 could be there, but then how would it become a 5 3 5? It would have to cross borders diagonally, but can only do that, which then causes a snake to touch itself. So I think whatever this happens, if this was a 2, a 5 goes there, which can only cross a border like this. It can't do that, otherwise you're stuck here. This snake can't go this way. So that will cause a 5 to go there, wherever the 3 goes. And then wherever the 9 is, breaks, because a 9 here forces a 7 into the cell where the 9 can see it. Forces a 7 into where 7 can see. And then a 9 here just fails. And a 9 can't go backwards, because, you know, can't touch itself. So I think it can't actually go this way, which is very interesting. The snake can't go this way. Can the snake go down this way though? I think it's more likely to be able to. So how would 5 jump spaces if it could do that? Well, again, I don't know how it works, because if the 2 did come down here, we would force 5 to be in that cell. Oh, yeah, and then 5 has to jump there because 5 can't be there. And then we're basically forcing the entire snake down this angle here, which already fails. So in no world can the snake actually go down this way at all, meaning we don't even need to think about it. The snake cannot do this, otherwise the 5s will have to repeat in the same box, or have to clash with this 5 in the column. So that means 5 can't go this way. This snake doesn't work, so that's not snake. Or maybe it could be snake if it did something like, I don't know what it would do. Can this be snake? I mean, it could always like wrap around itself, right? Well, we know the snake doesn't go down this way. So maybe with the pen tool, I will mark this as non-snake path, which means that it either goes here or there. Now can this be part of the snake? Have we proven that this can't be snake? The only way to get there by snake is to do this, right? Yeah, suppose, or more importantly, we can say, yeah, does this do that? Does it go there? If this was snake, does it go there? And I'm thinking that the answer is no, because after this 2 comes a 6, after that 6 comes a 5, and we know this is 5 can't go there because it can't jump borders anymore. It can't jump any borders. 5 can't go there because jumping borders is only possible if it did that, which locks itself in. So this can't be what happens, right? Meaning that if it went to this 2, it must go this way. If it went to this 2, where could it go? Where did the 6 go? Oh, that is very interesting. That is very interesting. I think we can force a 5 into that cell. So we know that it can't go this way, I think, which means I guess we can put another cross here. Snake cannot go there. So that means if it went this way, we have to push a 5 there, push a 6 there. Right, and this digit would have to have a 5 here, so it can jump borders over to here. Because after the 6 is a 5. It can't have the 5 be there, because it couldn't jump borders anywhere. You can't do this. So it will have to go here, which jumps borders to there. Now what about this one over here? Wherever that 6 is, the 5 is the next cell. Oh no, this is a 2, sorry. Yeah, so it's either here, which forces 6 here, which forces 5 here to jump borders. If it was this way, if we went down here, again the same issue would arise. But if we went this way now, the next digit is a 6. Wherever the 6 goes, it doesn't matter if it goes this way or this way. Where would the 5 have to go next? We already figured out if 6 is here, 5 can only go there to jump borders. But if 6 was here, a similar thing happens where 5 can't be here by this 5, and so 5 would have to be there, allowing it to jump borders. It could jump here or here, but either way, 5 is always there. So I'm pretty confident that whatever path it takes forces that to be a 5. Which I hope is true, and part of the snake. Which must jump borders, which means that either one of these are 5s. And it could be a 5-3-5, 5-3-5, or 5-3-5. I don't think that one is forced. But I guess it means that one of these cells is a 3. Is a 3. Oh, I'm sorry if you heard that. But that's really interesting because these 5s do force another 5 into that cell. Forces a 2 into that cell. And that forces a 2 into that cell. Yeah. Oh yes, yeah, exactly. This 2 now has to be one of those cells. But that removes this from being a 2. So this 5 can't actually go this way to hit a 2 there. Which means that the 5 must hit this 2 over here. So that is in fact part of the snake. Now wherever this 2 goes, however you get here, the only way to escape without going down is this way. So that is snake. And therefore, whoa, what color was it? There. Therefore this can't be a 1, has to be a 6, meaning this has to be a 1. Yep. This 5 must now go down because it can't go this way, so that's a 3. This has to be where it goes because it can't go this way, so that's a 5. I think that's what happens. So this is our snake right now. It goes this way or this way and we don't know, but we know all of these are no longer snake. Which is very nice. That tells us a lot actually. This means 6 is one of those cells. And therefore one of those cells. But we can't figure out where. This snake does have to go downwards because it can't go anywhere else. So that is part of snake. And in fact, because it is part of snake, it is just an 8, I think, because after 5 comes an 8. It can't go this way, so it has to go this way. And now we reach the 979, which means it has to jump borders. It has to do that. So that is part of the snake. The 3 after that is a 3-2-3, which has to jump borders again. So this can't be the next part of the snake because this can't jump borders anywhere. So it has to go this way because it can't go up. Right? I mean, it could be like this, but it definitely couldn't be upwards like that. So after the 9, it has a 3, which has to be this way then. Which then has to jump borders, so one of those is a 3. So this is definitely where 3 goes. And then this is definitely where 9 goes. And this is definitely where 9 goes as well. And we know one of these is a 7. Okay, wow. That really helps. This isn't snake, this isn't snake, this isn't snake. And now we know that because 3 goes in one of these directions, This isn't snake. This is definitely not snake either because it's penned in by all the non-snake cells. Wherever it goes, this can't be snake. It can't branch out, so that can't be snake. And I guess it can't end here because you can't have three. You can't have another 3 somewhere. We know the end of the snake is a 3, so it can't end anywhere here. So that's not snake. This can't be snake either. Well, it could go this way. So I guess this could be snake. But wow, have we made progress? Okay, where does 3 go in this box? Let's finally do some regular Sudoku. Those 3s see everything but that cell. Oh, I'm ecstatic. 6 is one of these cells. And then I guess 8 is one of those cells. Yeah, okay. Oh, well that's interesting because that must be snake. Wait, must that be snake? No, this could be snake if it does that. I realize that now, so this doesn't actually have to be non-snake. And in fact, I think that's true because after 3 comes 2, and it can't do that because there's already a 2 in the column, so it must do that, which must grow out to here. So we have even more digits. That's 2, that's a 3, which must then grow. It can't go this way, so it has to go this way. No, because after 3 is 8. Yes, after the 3, 2, 3 is an 8. So it has to take this 8. It can't go here or here because those can't be 8s. So that has to be 8, which is part of the snake. Next we have 4, 6, 2, 6. Okay, the snake must now jump borders again. But I can say that those are not snake. This can't be snake because it can't end there. There's already a 3 in the column, so that can't be snake. It could go down this way. Although, I guess if it did, that fails because the 6 is seeing a lot of stuff. The 6 here must jump borders, right? 6 to 6. And so, which way can it jump? It could go up here, I think. It could go up there. But it definitely can't go down here. Because then it will have to jump across this border, which forces a 6 into there. Right? Because you could have like 8, 4. If you went down here, it was 8, 4, 6. And then 6 have to jump borders to here. Yeah, so it can't go down this way. So this is definitely not snake either. I mean, it has to go up here. Oh, well that's very interesting because I think this is another thing I should have taken note of. If it goes up this way, it couldn't jump borders immediately. Because then the snake would have to jump borders again because it would then hit a 6, right? 8, 4, 6. They have to jump borders immediately. The only possible one is there. And here it's very similar as well. This 8 would see a 4 there. Sorry, yeah, it can't go this way because you already have a 6 here which fails that. So a snake can't go this way. It can't go this way. And so I'm pretty sure wherever it goes, I have to hit here. Which then jumps borders to either there or there, but this doesn't work. So we have to jump borders to here or there, right? So one of those is a 6. And then this is definitely a 6 as well. And then one of these has to be a 4, which is where the thing is. Yeah, before the 6 becomes a 4. And then we have to jump to 6, like that. Right? Yeah, I would say so. I think one of these is a 2. I think. Six. Oh, wait a minute. Oh well, I mean we know one of these are 6s, so that's not a snake. That's not a 6. What did I say? That's not a snake. That's not a 6. Means that's a 6. Yeah, that makes sense. Well, these are 6s, so that's not a 6. Okay. Wow, this is getting out of hand. After the 6 comes a 4. Oh my goodness. Okay. Yeah. Oh, actually I can say that 2 is in one of those cells. Because however you get to 6, you couldn't go into the other remaining cells at all. So 2 is in one of those cells. But there are several ways to get to different 6s. Yeah, and both are valid, I believe. Also, after the 6 comes a 4, which is very interesting about this 6. Right, this 6 is only reachable you can't do this to get to that 6. You can only do this to get to that 6, which then forces a 4 up here, and then forces a 3 somewhere. Oh, but that fails, because where does this snake go to get its final digit 3? It would have to be up here, right? Which clashes with that 3. So I don't think it can go this way, which is really interesting. It can't go this way. If it went this way, okay, I'm going to go through that logic again. If it went this way, it couldn't then take this 4, because you can't go take this 4 and then take this 6. Right? And you can't do that because it can't jump borders like this. So if you took this 6, you'd have to take this 4, go up, take this 2. You can't take this one because this one doesn't reach 6 in time. You'd have to take this 2. And now for this snake to keep growing, it can't go down. It has to go up. That would be a 4 then. For this snake to keep growing to its final digit, which is a 3 I believe, it would have to go upwards because it can't go this way. So we have to do that. But that forces a 3 here, which sees that. So that doesn't work. Meaning that it can't take the 6. So I'm pretty sure the 6 goes there. Which is also a part of snake. And now this 6 sees one of these being a 4. Because it can't take the cell layer, it can't do this, yeah. So one of these is a 4. And then after that will be a 3. So can we see how that affects things? Well, these 3 see a lot of these cells around it. Right, a lot of very interesting looking cells. So if it took this 4, it can't go up here because there's a 3 there. It can't go down there because there's a 3 there. And then we'll have to go this way. If it took this 4, it can't go this way because there's a 3 up there. It can't go this way because there's a 3 over there. And so it would have to go this way. So a 3 that goes this way, or a 3 goes this way. So one of these is a 3, which I think both are fine right now. I think. Yeah, but it's crazy how many different possible ways to finish a snake are. Okay, well I guess you have to do regular Sudoku to figure out where everything goes. Like for example, where does 2 go in this box? Well 2 can't see those cells, so that's a 2. That makes this a 7 and therefore part of the snake. Because it has to be 979, so that's not part of snake. This is 174. Which means that this isn't 1, this isn't 7. Okay, it doesn't break yet. I'm pretty relieved that it's not broken yet, but we're still really early in the game. We're still really early into the Sudoku. I haven't actually done a lot of stuff yet. But what do we have? Three is in one of those cells. Does that help? No, it doesn't disambiguate much. Oh, well, where does 3 go in this box, I guess? 3 sees those. These 2 3s see those, so that must be a 3. Which is not snake. Alright, yeah, okay. We figured out that the snake must take one of these, one of these, one of these, and one of these. Which are the only cells it takes. So these are the only cells that can be snake. And therefore the rest of the cells cannot be snake. So let's just quickly mark those off to make sure we understand. And I believe this is actually indeed 25 cells. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Wow, these cells is 1, 21, 22, 23, 24, 25. Okay, so we do indeed have 25 digits. Okay, that's helpful. Alright, I wanted to say something about this being a 3, because if it was a 3, you'd realize that in this box, 3 is actually forced into this cell. So if this is a 3, you know, all of these would be seen, and so that would be a 3. And I was like, at first I was like, is this possible? And yeah, it is, because it doesn't say that one of these has to be 3, it says at least one of these has to be 3. If the snake could go here, this could be a 3, that's fine, because it's not part of the snake, it doesn't have any issues. So in fact, these could be both 3. That's okay. I mean, it's just that one of these is a 4. It's not both because they're in the same box. But these could be both 3s. That's fine. Okay, what about 3? Yeah, 3 could be one of those cells. I think we already saw that. And here, 3 is in one of those cells. Oh, but I guess none of these can be 3s, which is very interesting because 3s here or here would eliminate these from being 3s, and we know there's at least one 3 there. So as opposed to our previous argument, these can't be 3s because then they would make these both non-3, which fails the snake at all. So these can't be 3s. Meaning that, meaning that in this box, where can 3 go? This 3 sees those cells, this 3 sees that cell. We have to figure out these 2 can't be 3s because they see both cells here. And so 3 is in one of those cells, which means I'll mark those as 3s. Now in this box, where does 3 go? This 3 sees those, this 3 sees those, these 3s, not that, sees those. So this must be a 3. Now obviously we can't mark this as snake yet because we don't know it actually ends here. It could end there if we wanted it to. But at least we've proven that that's a 3. So that is most of the 3s done. Okay, what about these 6s? They see all those cells, so 6 must go there. And in this box, yes, these 6s see those. This 6 sees that, so 6 goes there. In this box maybe? In this box, 6 sees one of those cells. I'm gonna remove the X's. We don't need those anymore. And in this box, again, 6 sees one of these cells, so that's not helpful at all. We've got most of the 6s though, I believe. Yeah, alright, in this box, 5 goes in one of those. 5 sees those cells, so it goes there. The 8 must therefore be there. Sorry, not 3, 8. This is therefore a 1, 4. This 1 sees that, so that's a 4, that's a 1. That doesn't help. If this was a 4, that would help, forcing that to be a 4. But it doesn't help. What are these cells? These cells are... Well, these cells are 1, 7, 1, 2, 7. These 2 1s see those 2 cells, so 1 goes there. 2 sees that, so that's a 7. That is a 2. These cells are 4, 5, 9. 9 sees those 2 cells, so 9 goes there. This means that must be a 4 and part of the snake. And this is 5, I guess, which is just there, it's just hanging out. Which means that... Well, this 2 sees that, so that can't be a 2. Meaning that must be the 2 and part of the snake. This either still works. Wow, actually. Yeah, either path still works. But this 2 sees that, so that's not 2. I mean, that's good, because that's 2 now. Okay. What does 2 go in this box? These 2s see all but this cell, so that's 2. Actually, what are these cells? Do we know those? 2, 3. There's 4 and 7, which we can't disambiguate. These cells are 8 and 9. Again, we can't do anything about that. But okay, that's progress. It's useful. What are these cells? Well, they're 4, 7, 8, and 9, which we haven't done a lot with, but okay. What are those cells? Those are 1 and 8. Disambiguated. Oh, unambiguated. Very ambiguous, in fact. Those are 4, 5, 7. Doesn't give us much either. This can't be a 7. That can't be a 5. Which doesn't help. No, we've already seen the 3s. 7s? In this box, maybe? No, 7 can be anywhere in those cells. And then up here, could be anywhere there. And here could be anywhere in those cells. Yeah, not helpful. 5s? I don't see anything either. No, it's not helpful at all. 6s, I think we've seen those. 8s. 8s look really bad still. Yeah, 8s don't do much. 9s. Oh wow, where are the 9s at all actually? I don't see much of 9s. Nope. Oh, I'm sorry about that. Oh, I see. Where does 9 go in this row? We know one of these are 9, so none of those are 9s. That's not 9, so that's 9. That's 8. Okay, and then this is 4, 7, 9. I can mark those down. This is 7. And then that is... well, we don't know what that is, but... can this be a 4? No, it can't be a 4. Because a 4 would force this to be... yeah, one of these are 4s. If this is a 4, this is not 4, and this is not 4 because these are both seen by that. So it doesn't work, so it's a 9. That's not a 9. This isn't a 9. But that means that's snake. And that isn't. Good. We're getting somewhere, maybe. This is 4, 6, 8. 4, 6, 8. What can we remove? It's gonna be 6. That's it? Wow. Alright, fine, I guess. This can in fact be 4 now, if that's a 4. Well, no, because one of these are 4. Yes, okay. So, yeah, okay. So it is sort of like an X-Wing. Because these, one of them are 4s, at least one. One of these are 4s. So that makes at least 2 4s in these 4 cells. Now this entire row is made of 2 sets of the digits 1 to 9, which therefore will contain exactly 2 4s. There's one here, there's at least one here. Those make up all the 4s in these 2 cells, so this can't be a 4. Alternatively, you could have said if this is a 4, then that must be a 4, which breaks this pair. That also works, yes. Not exactly sure where that goes anymore though. But we know exactly one of these are 4s now, because exactly one of these are 4s. So I guess that is somewhat useful. What are these cells? 4, 6, 7, 8. Yeah, okay. Can't do much about that. I can try putting them in though, because I think this can't be a 4 and 8. This can't be a 6. But does this really help much? Nah, it doesn't. Nope. Okay. Now what? One of these are 3s, we know that. They can't be 6s. They can be 4, 7, or 8 as well. This can't be 4, 8. Actually, this is 3 or 7, isn't it? But how do we disambiguate that? We can't. That's a little frustrating. What are these? 4, 7, 8, 9? Yeah, I can't disambiguate that either. I know one of these are 9s, but that doesn't help. One of these are 9s. I know one of these are 9s. Yeah, doesn't do much. I don't think the snake really needs help anymore. We don't really need to touch the snake. It's either this or that. Does that really change much? I mean, it changes where the 4 goes. But does that do anything? 4, I mean, a 4 here would affect this pair. A 4 here wouldn't do anything. It might affect this pair, I guess. Do we look at other rows, like do we look at certain columns and see where things can go? 4 here, 4 there, 4 there, but 4 here means 7 there. I don't think that helps. Unless I'm not seeing something. Can a 1 go here? I mean, yeah, it sure could. Huh. Fives are one of those cells, but 5 could be, well, 5 are one of those cells, which I guess is something. Doesn't really help though. I'll say if the snake goes this way. If the snake goes this way. Oh, we are past the 1 hour mark. Uh-oh. 4 here would make this an 8. This would not be a 4. Oh, I'm sorry about that. Let me just continue going through. I was talking to someone. But the logic is not getting into my head right now. I've been staring at this for a while, haven't I? Making zero progress. I want to say it might be a hidden triple somewhere that I'm not looking at. I don't think it has to do with the snake, but it could be something to do with the snake. 4 here forces a 7 here and there. Those are both 7. Wow, okay. What does that do? Not much. It really only sees that box. That can't be. That's a 4 now. I mean, that would no longer be 7. And those are not 7. And then 1 7 was one of those cells. I mean, that's not 1. It's a 1. That's a 4. Oh, wait a minute. Yes, okay. Well, 4. Could this be a 4? We say like this couldn't be a 4, could it? Yeah, because of this quote unquote X-wing here. So 4 is in one of those cells, definitely. That's something. 4 is in one of those cells, definitely. So, what does that mean? It means that those can be 4s. A 4 is in one of those cells then. Could it be in that cell? 4, 4, 4. Yeah, I guess it could. It's either a 4 here or a 7 there. What? I am shocked by my inability to do this puzzle. 4 5 4 7 4 7. That's fine. You'd have 5 7 8 to do that. 5 8 9, sorry. Okay, so if this was a 4, it's just a 4. But if this was a 4, that makes this a 4 7 pair. This would then be a 5 8 9, and these two 5s see those cells. So this would then be a 5. So this is either a 4 or a 5, I think. Which forms a 4 5 7 triple. Oh my goodness, that forms a 4 5 7 triple. What the? There is no way that was intended, but that means this is an 8 9 pair. And I know it's not intended because it doesn't do anything either. Like, what? This doesn't do anything. What does this even do? Oh my goodness. This is a hidden triple. No. I mean, did we prove that this can't be a 9? It could be a. I mean, if we didn't look closer, this could be a 9. What about that cell? Oh my goodness. This puzzle is in fact driving me a little bit crazy. I thought this was going to be an easy one. This was marked 2 out of 5 difficulty. I still can't stop being like very butthurt about that. You told me this was going to be easy. But no, it was probably just some expert doing this, and I was like, oh, this is fine, I've seen this before. I mean, it is like normal Sudoku at this point. It's gonna be a 9, this gonna be a 7. This is 4, 7, 8, 9. 3 is one of those cells accompanied by a 7 or a 4. Go there, but one could go there. Yeah, because one of those is a 1. 4, 3, or 4, 3. 4, 3. I think there's something significantly incorrect about this being a 4, 3. Shall we bifurcate? Shall we bifurcate? 4, 3. 3 here by Sudoku. 7. 5. 4. 7. So this is no longer 7, meaning 7 must be one of those cells. 7 here, 4 there. 4 here, 7 there. That's fine. What? That works. What if this is the case then? 4, 5. This has to be a 5. Oh wow, this is a 5. This is a 5. If 5 was there, isn't 5 in one of those cells? We figured that out, didn't we? Yeah, 5 is one of those cells. How does that even help? There's some weird logic going on here. We have 4 5s, 5s here. Well, these are 5s. Can this be a 5? This would then be a 4. And this would be a 5. And then this would be some random digit that isn't a 4. But it could be anything. What the? This is 1 4 5 8 9. This is not 1 8, so this is either a 4 5 or 9. This is not a 9, but this could be a 1 4 5 or 8. 1 4 5 8. Wow, help me escape this purgatory. What is this? What am I looking at? I mean, this is... If that was Snake. This is Snake. One of these is a 7, one of this is a 7. One of these are a 7, and then one of these are a 7. That's a very fine... This could be like this, it could be like this. It can't be this though. Which does make sense, because you can't put 7 here, you can put 4 in both of those cells. I really hope it's just not something that I'm randomly missing out. Oh no. What if it is? I would be destroyed by the comments. 4, 1, 4, 7, 8. What's the last digit here? Is it 2? Right, well 2 is in one of those cells, I guess. I guess we know that. And then 1 is in one of those cells, I guess. What else is one of those cells? 1 is in one of those cells, actually. What the heck is this snake doing? What is this snake doing? If it went this way, it would have to go this way. If it went this way, it would have to go this way. Some weird rule. Maybe. If it went this way, we know then this is a 5 and this is therefore a 5. If it went this way, we know that... Well... Oh! Wait a minute. If it went this way, is this always just a 5 then? If it went this way, this would be a 4, that would be a 5. That means this isn't a 5 and that's be a 5. But if it went this way, that would also be a 4, meaning that is not a 5 and therefore that would be a 5. So is this always just a 5? What if this was a 5? Yeah, if this was a 5, then this would be where the snake has to go. This would be a 4 and this now doesn't have an option. So this can't be 5 and so that's a 5. Okay, new digit, new digit. Does not help, but it does imply that one of these are 5s. New digit. For real. 2 goes in one of those cells, forming some level of X-wing. Oh my goodness, one of these are 5s. 5 here, 4 there. This is again 1, 4, 8, 9. Well, it can't be 5, 9 now, so it is just 1, 4, 8, 9. Oh, 1, 4, 8, because it can't be 9 either. So it's a 1, 4, 8. It doesn't say anything, unfortunately. Because this could still be a 5, couldn't it? Right? If we went this way though, yeah, this would then be a 5. If we went this way, then this would be a 5. And I don't see anything wrong with that. Is there any 5 we haven't been looking at? No, it's just that. Okay, what if we went this way? 4, 5, 5. 4, 7, 4, 7. 4 here means that's no longer 4. So that's 4 or 7. It's 4, 7 pair, 4, 7 pair. This would then be 1, 2, 8. Right? This one sees that. This is 1, 2, 8. Actually, this... could this be a 1? No, this can't be a 1. Wait, could it? It could be a 1. Wait, what am I saying? Could it be a 1? Oh my goodness. Then we have a 2 and an 8 here that we need to worry about. Where's the 8 supposed to go? It can't go there, but it could go in one of those cells. What are these? These are 3, 4, 7, 8, I think. Can I do anything with that? This can't be 8. That can't be 3. Nothing. Nothing much I can do with that. 4, 6. This is almost a quadruple. Nope. Goodness gracious. 3 here means 3 there. This is 3, 4, 7, 8, 9. Okay, let's mark 3, 4, 7, 8, 9, but this can't be a 9. Can't be an 8, can't be a 4. So it's either 3 or 7. Somewhat interesting, maybe. I mean, what if this was a 7? This couldn't be a 3 then, could it? 7. 7 here pushes up one of those cells, but I think that has to be a 7 then. I mean, not entirely sure, but could this be a 4? 4 means 4 is there. 4 here means 4 goes there. 4 over there means 4, 7 pair here. Also means that these are both 4, meaning that's a 4. Wait, what? Yeah, 4 means that's a 4, 7, so 1. 7 here removes that, makes that a 3, makes that a 3. This could be a 7. I think that's the only thing that we're worrying about here. Yeah, I'm sorry. I was like, I was gonna say something super dumb about 7 in this box, which already exists as a 7. I really have nothing else though. 7 is one of those cells, 7 is one of those cells, 7 is one of those. We've seen that before. 4 is one of those cells, one of those cells, and one of those cells. Actually, yeah, if 4 is one of those cells, what could any of these be for? Yeah, 4 is in one of those cells. What the? So none of these are 4. Okay. Does that help? That's 3 or 7. That's 3 or 7. 7 or 8. Oh, this 7 sees that. Wouldn't even see that. So that's an 8, right? I hope. I hope I did all my logic correctly. That makes that a 9, that's an 8. That 9 sees that. That is a 4, 5 pair. Whoa! 7. That is no longer a 4. And in fact, because there's no longer a 4, the snake must go this way then. Because it now can't go this way. So I hope that helps. Meaning this is a 4, that's a 3, that's a 5. This 4 means that's a 4, so that's a 7. Unless it could also be 4. No, yeah, it's a 7 because a 4 is here. Okay. Yes, okay, that is right. This is what we have so far. 4 has to be here because it can't be 5. This can't be 4 or 7, so that's a 5. That's a 7. That sees that, so that's a 4. That is a 9. That is not 4. This 3 makes that a 7. That's a 3. That is not 3. Okay, pretty excited about this. This is 1, 2, or 8. This can't be 1. That can't be 8. A nice chocolate teapot. Thank you very much for that. This can't be 8. That can't be 8. So that's just a 4. This isn't 4 or 7, so that's a 1. That's an 8. That's a 1. That's an 8. That's a 2. That's a 1. That's a 4. That is a 6. That's an 8. That is, this 4 means that's a 7. That's a 4. So that's a 6. This is a 2. These are... Oh, sorry, these are not snake. What am I doing? Sorry, I was sorry, like, oh my goodness, what have I drawn? These are 9 and 7, which have to be 9 here, 7 there. Oh my goodness. Finally. Oh, wow, this puzzle was one tough one to crack, even like right from the start. Oh, I was in for more than I expected. This was really fun. Super satisfying at the very end. We had a very hiccup regarding regular Sudoku. So I'm just gonna say that's because I'm incompetent at Sudoku at all in the first place. I can't do that properly. But the beginning section was in fact quite tough. Like figuring out all the options and stuff. I really like that part. Because it's a lot more restricted than you think, especially about these jumping borders things. Like the 323, 979, 535, those palindromes. Yeah, I think it was really important that we said that those need to jump borders diagonally. And we did prove it in this video, so that is very cool. Oh, what a puzzle. Oh, I'm still feeling all the adrenaline from solving it. Well, I hope you enjoyed solving that too, I really did. Alright, I will see you now, bye bye.